So this is just a short video showing you how to implement correlate the correlation coefficient, what we've been referring to as R, in Excel. So how we get that number R, which tells us how correlated two of our variables are. Okay, so the way to do this, I think, is probably just through some quick examples. So here I've got the some data on the number of disturbances, and that's a euphemism really for riots, between 1810 and 1821, and this is approximate to a kind of real historical a data source that we have. Next to that, I've got the same, for the same years, I've got the average price of wheat in shillings per quarter. Okay, so we can use the correlation coefficient R here because our variables are, well, our disturbances number and price of wheat are both continuous variables, and they're interval variables here. For the disturbances, you can't have half a disturbance, whereas we've got kind of a more defined ratio variable here for the price of wheat. So this isn't kind of just an ordinal variable, as in you're either a nobility, middle class, or lower class, where there is kind of an order to it, but it's fundamentally doesn't have kind of a units in between those, and it's not a nominal. They're not nominal variables in terms of just place names or something like that. So we can use the correlation coefficient R to measure the relationship, or rather test if there is a relationship between these variables and how much there actually is. So the first thing to do, as I was saying the other day, is to create a scatter plot of these. So we don't even bother calculating R, even though it's really easy to do in Excel, if it doesn't look to us visually like there's a correlation, and that there's no reason for us to believe that there would be. So there is a reason to believe there might be, which is that if people are very hungry because they can't afford the price of a basic food like bread, then they might turn to violence and unrest to express their protest at that situation. So there's a reason these things might be correlated, or might be affecting each other. So let's quickly chart them up. So the way to do that in Excel is to find somewhere to the side of your data, go Insert, and then a scatter chart. And the basic type is what we're after. So we've got our blank scatter chart ready to go here. And then we select Data, and we're going to add a new series. And we'll call this Disturbances versus Wheat. Now, in terms of the actual calculation of the correlation coefficient R, it doesn't matter which way round our two series are. It doesn't matter whether we're going to end up having the price of wheat on the bottom and disturbances on the y-axis. Correlation will be the same either way round. It's different if you're doing a regression analysis. But the convention is that you put the causative variable, or the one you think is causing the change in the other, the independent variable, you put that on the x-axis here. Now, obviously, in our model here, we're not saying that disturbances necessarily change the price of wheat. That'd be quite a complex line of causation to argue that. It's much easier to say, and much more likely to say, the price of wheat is likely to have affected how many disturbances there were. So let's put the price of wheat on the x-axis, so series x values, insert the range, and you can select them like that. And then the y values, let's give those the number of disturbances. Okay, and click through, and press OK again. Now, that's plotted them up for us. Now, note, yes, we had our year's data here because it was useful to us as collecting it, and we want to know which year this data relates to, but that's not what we're interested in on the chart. We're just literally comparing the relationship between, if you have this many disturbances, it's likely the price of wheat was this, or if you have this price of wheat, how many disturbances might there have been. We're not interested in whether they, in this case, in what year they happened. So each point on the graph here reflects where two of these things match up. So here at the, we should really put some labels on, it'd be easier to see. So a price of wheat of, say, less than 60 which was 55. So which one's that? The bottom one, 1821's had a price of 5, and 55. So hence why it's there on the x-axis, this point, and then on the y-axis, it's here just between 10 and 20, and yet when we come across to check, that's 15. So it's giving us the coordinates for where this is, dependent on as far along to the right, depending on the price of wheat, and as far up or down, depending on the number of disturbances. And what we can see is that we've got what looks like a pretty good positive correlation, as in, as the price of wheat increases, so too does the number of disturbances or riots increase. So this looks like a positive correlation, and it's worthwhile finding out via the coefficient how strong that correlation is. So just type wherever you're going to put want your answer to appear, just below the graph normally, equals correl. So there we are. Make sure you don't type the full word correlate, it's just C-O-R-R-E-L, and then open the brackets. And it's asking us for 2 arrays, which just means two lists of numbers. So the first one, we can type in the references if you want, or you can just do what I'm going to do and select them via the mouse. And the order doesn't really matter here, but we'll be consistent. So we'll say the first one is our price of wheat data set, and we'll insert a comma to move to array 2, and we'll have that array or list of numbers as the number of disturbances. And when we press enter, Excel's going to apply the formula that I have given you in the previous video, and we'll come up with an answer as to what whether these two are correlated or not. So it has given us the answer of 0.95. Now remember that the R will always be between -1 if it's a really strong negative correlation, so if it was going like this, downwards. 0 if there's absolutely no relationship and the points are all over the place. And it will be near to 1, well, the nearer you get to +1, if it's a strong positive correlation, which is what it looks like we've got in this case, at 0.95. So this one looks like there is a strong positive correlation between the price of wheat and the number of disturbances. Now, this isn't a regression analysis. It's not telling us the stats aren't what is telling us that the price of wheat is causing the disturbance to go up. That's my historical hypothesis. The stats are just telling me that there is indeed a relationship between these two, and it's up to me to make the argument as to why that's the case. So I'll quickly give you another example. So this is some data showing the price of the consumption in pounds, and what I mean by pounds here is the imperial weight, so how much of a product people are consuming for both coffee, sugar and tea, and over a period of 1850 to 1865 when tea and coffee drinking were taking off in the UK. So one analysis we might do is suppose that there might be a relationship between the amount of coffee and tea people were drinking and the amount of sugar that people were consuming. So as people drink more tea or more coffee, have they consumed more sugar? So that's our hypothesis, and remember this isn't in prices, this is in a measurement of weight of product on average consumed by each individual, so hence the per capita. So it's really applicable. We can use the R statistic or the correlation coefficient as it's known, because again this is ratio data and continuous numerical data rather than nominal or ordinal. Okay, so we'll quickly put this together. So if we go insert, scatter charts, the basic one, select the data. Now we might suppose that it's drinking more or consuming more coffee or tea that causes a change in sugar, so let's put that on the x-axis. Let's just call this first one coffee versus sugar. So this is the x-axis. We want to put on the independent variable here, which is in our case coffee consumption, and then the thing that we're expecting to see changing, the sugar, we'll put on our y. and press OK. Now we're going to do a bit of formatting of the graph here because it looks like our units aren't starting properly. They're starting at 0, and it's quite a narrow range of variables, and it would be easier for this axis to start at 1. So let's just set the minimum. If you click on the axis labels, and sometimes you have to come across this axis option and set the minimum to 1. Yeah, so that gives us a clearer picture. Now there doesn't really look like there's a clear correlation here. Yes, things are always up here in this kind of 25 to 40 area, but how high they are doesn't seem to be affected by how far along to the left here they are along our coffee consumption axis. But we can just do a double check with Corel, and you probably wouldn't bother doing this normally, to be honest with you, but I want to show you what a weak correlation looks like. And you can just select via the mouse. So yeah, so we've got a negative correlation. So if there is anything, it's going down that way. It's going to be as you drink, as you consume more coffee, it seems that you actually consume on average slightly less sugar, but it's a very, very weak effect. So it's 0.34, so not very, very weak. It's a significantly weak effect, weaker effect than what we saw in the previous example. So you probably actually wouldn't call this a correlation. You'd probably say although the R statistic is minus 0.34, suggesting a slight negative relationship, this is unlikely to be kind of worthy of saying there's a correlation between these two variables. Now what I'd like you to do is repeat that for tea and sugar and see if there's a different relationship there. But then I'd like you to consider the bigger question of, are we really measuring a real effect between these two things here? I mean, for instance, don't people consume sugar in a lot of other things? This isn't just the figure for how much pounds of sugar people consumed whilst drinking tea. So perhaps there's a third variable, a hidden variable that could be explaining the either increase or decrease in people's consumption of sugar and tea that affects both of them, and is leading us to believe that they affect each other. And after you've done that, I'd like you, if you're in the workshop doing this, to try and apply some of this stuff to the data you're working on for your group projects.